Let me turn off these lights. Okay, so I want to do this example with you guys. You had one on your homework like this, so if you didn't get it done on your homework, we'll do one like it here. And then we'll go on to the arc length and surface area. So find the area of the region common to the two regions bounded by the following curves. R equals to minus 6 cosine theta. I'm going to sketch the graph first. What intervals do we use for cosine theta? Pi over 2. So pi over 2, pi, 3 pi over 2, and 2 pi. Cosine of 0, 1 times the negative 6, negative 6. Cosine of pi over 2, 0. Cosine of pi, negative 1 times the negative 6, positive 6. Cosine of 3 pi over 2, 0. Cosine of 2 pi, 1 multiplied by negative 6, negative 6. So there's our graph. Notice that we have on there where it crosses our x-axis, so I have all the tangents to the pole represented there. So I'm going to go over here and I'm going to sketch the polar coordinate curve. I only need my quadrant angles. At 0, it's negative 6, so negative 6 is going to be to the left for 0. At pi over 2, it's 0. It's negative in that region, so I drop below, come in tangent to pi over 2. At pi, it's going to be 6, so it goes back out. It goes once around from 0 to pi. It goes twice around from 0 to 2 pi. So from here is one complete loop. Now, let's look at the next one, 2 minus 2 cosine theta. Here again, I have intervals of pi over 2. At 0, what is cosine of 0? 1. So I have 2 minus 2 times 1, which is 0. So it's 0 right here. At pi over 2, what is cosine? 0. So I get 2. At pi, what is cosine? Negative 1. So I have 2 plus 2, which is 4. So that goes up to height of 4. And then it's going to come back down. So let's graph that one. At 0, it's 0. I'm going to graph that one with orange. At pi over 2, it's 2. Oh, it's unfortunate it chose that to be 6. Let's make my original graph a little bit bigger than that. That's going to be 2, 4, 6. So it comes like this. It's a circle. It just doesn't look like one. I'm going to try that one more time. That's a little bit better. So now in the orange one, we start here at 0. Then we have a length out of 2 on pi over 2. And then at pi, it's a length of 4. At 3 pi over 2, it's a length of 2. And then at 2 pi, it goes back to 0 tangent to 2 pi. So that's a cardioid. So we're looking at the intersection of the cardioid and the circle. We want the area common to both of them. So the area common to both of them is going to be this area. Let's see, find the area of the region common to the two regions. So I'm looking at, I think I have my question worded wrong. Let me double check that because I want a different part of this. The one I'm trying to do. No, I do. That's the area of the region I want. Okay. My problem is that this circle isn't very circular yet. That's horrible. Let's try that one more time. I know what I'm trying to get to. There we go. So what we have here is this area common to those two regions. Now the question we have to figure out is if we superimpose our angles for our pie-shaped region areas, for the cardioid it's going to look something like that, our pie-shaped wedges. And for the circle, if I'm ending on the circle, then I have to have my angles coming up over here on that side. And they meet right here. Let's make this, I don't know. We'll make it gray. This is where the intersection is going to be. So for part of that, what you have happening, if I may make a big circle like this, and then the cardioid comes through it, you're looking at this region right here. This area right here comes from your circle. Does that make sense to you guys? You have part of that region cut off by the circle, and then part of the area comes from your cardioid. And I'm going to cut it in half and just do half and half. Does that make sense? So I'm going to call, let's get this back to blue ink. I'm going to call this region right here A1, and I'm going to call this region A2. And I'm going to multiply my whole answer by 2. So the area is going to be 2 times A1 plus A2. And I'm going to make A1 is 1/2 the integral. Now we have to figure out for the circle, where does it start there at the origin? When is the circle at the origin? At pi over 2. So that's where it starts for the circle. And then it goes up to the point of intersection. So how do we find our point of intersection? Set the two equations equal. So we're going to have -6 cosine theta is equal to 2 minus 2 cosine theta. I'm going to add my 2 cosine theta to the other side. And so we have a -4 cosine theta is equal to 2. Or cosine theta is equal to a -1/2. When is cosine theta equal to a -1/2? Two pi over 3. So this goes from pi over 2 to 2 pi over 3, and that is a circle, so it's -6 cosine theta squared d theta. Then the cardioid starts at 2 pi over 3, and it goes up until it crosses that negative x-axis, which happens at pi. That would be this height right here. And then that's 2 minus 2 cosine theta squared d theta. You integrate both of those, and you get your answer. So you guys had a homework problem similar to that. Any questions on that? Okay. With the endpoints of the integrals or with the plug-in? Okay, so pi over 2 comes from the graph of the circle when I am here at 0. And if you look at your original graph up there, that happens at pi over 2. And then the 2 pi over 3 is the point of intersection where the cardioid and the circle cross up there in the upper half. 2 I set them equal to each other and solve. And found where they're equal to each other. Yeah. There's no other way to do that. You have to set them equal. Okay. This will be, I'll repost that slide up on eClass after class today. Let us go look at the lecture that was for today now. We are starting today with arc length and surface area. So on the back of your handouts, I think I put it on the back of your handouts. I did. Yeah, the formulas for the arc length and the surface area. This is a formula for the arc length. It says let f be a function whose derivative is continuous on an interval. Then the length of the graph of r equals to f of theta from theta equals alpha to theta equals beta is the formula integral of f of theta squared plus f prime of theta squared. Now, from before, what I knew for parametric equations is that the arc length went from A to B, and it was x prime squared plus y prime squared dt. Remember that from section 9.2? That was our parametric equation formula. So let's calculate our x prime. X is going to be r cosine theta. So that is the same thing. R is our f of theta, so that's f of theta cosine theta. So let's take x prime. It's going to be f prime of theta, derivative of the first, times the second, plus the first. What's the derivative of cosine? Negative sine. So this becomes f prime of theta cosine theta minus f of theta sine theta. Now let's do y prime. Y is equal to r sine theta, which is our f of theta sine theta. Let's take the derivative. Y prime is going to be f prime of theta sine theta plus f of theta times the derivative of sine, which is cosine theta. So there's our derivative. Let's do our x prime squared. That's going to be f prime of theta cosine theta minus f of theta sine theta. When I square it, I have to FOIL. So I get an f prime of theta squared cosine squared of theta minus 2 f prime of theta f of theta sine theta cosine theta plus f of theta squared sine squared of theta. Now let's do our y prime squared. So I'm going to write the y prime squared over here so we can see what we're plugging in, but I'm going to put the terms down below and add straight down. It'll make life so much easier for me. So this becomes f prime of theta squared sine squared theta plus 2 f prime of theta f of theta sine theta cosine theta plus f of theta squared cosine squared of theta. Now add straight down. Tell me about the middle terms right here. They cancel, yes. Our middle terms cancel. And on the first term, you have the f prime squared for both of them, but you have a cosine squared plus a sine squared. Yeah. So I'm going to get an f prime of theta squared. Let me write it down so you can see what happens. Sine squared theta plus cosine squared theta. And then on the last one, I have an f of theta squared sine squared plus cosine squared. So that becomes an f prime of theta squared plus f of theta squared. That is what they have under the square root right there. So they're using the parametric equation form for this. Question? This 2?
Yeah.
They cancel. Yeah, minus 2 of them up here, you have plus 2 of them down here. Minus 2 plus 2. Minus 2 apples plus 2 apples. Yeah, they cancel. Oh, I want that in this one. Okay, so that's our formula for arc length. Arc length, you would only have to graph if they do not give you the intervals for the arc length on it. If they give you the intervals for the arc length, you don't have to graph it. If they don't, then you do have to graph it to find out what the intervals for the integral are. Let's look at an example. Find the length of the arc from theta equals 0 to theta equals 2 pi for the cardioid, r equals 2 minus 2 cosine theta. So they didn't tell me what the intervals are, so I actually have to, theta equals 0, theta equals 2 pi. They told it to me, so I just plug it in. If they hadn't told me that and just told me for one circuit of the cardioid, then I would have to graph it to make sure that one circuit is 0 to 2 pi, not 0 to pi, because sometimes it's 0 to pi instead of 0 to 2 pi. So they told it to me. All I have to do is find my r prime and square it and square r. So what is r prime going to be? 2 sine theta. So what is r prime squared? 4 sine squared theta. And let's do r squared. That's going to be a little bit more difficult. We have to FOIL that. So we get 4 minus 2 times 2 cosine theta plus 4 cosine squared theta. So simplify 4 minus 8 cosine theta plus 4 cosine squared theta. Now let's add r prime squared plus r squared. And I get 4 minus 4 cosine theta minus 8 cosine theta plus 4 cosine squared theta plus 4 sine squared theta. What does that 4 cosine squared plus 4 sine squared become? 4. So I have 4 minus 8 cosine theta plus 4. What is 4 plus 4? 8 minus 8 cosine theta. So the arc length is going to be the integral from 0 to 2 pi of the square root of 8 minus 8 cosine theta. Now, you are going to be tempted to try and integrate that in the form that it's in. That's going to be painful. But we can switch that form. So notice, watch very carefully what I'm going to do. If I have an 8 minus 8 cosine theta, I'm going to factor out the 8 and I get 1 minus cosine theta. On your trig identity sheet, you know that I think it's half angle formula is the name of it. I always get the name wrong. You have sine squared theta is equal to 1 minus cosine 2 theta all over 2. Remember that formula. I'm going to use that formula. I have a 1 minus a cosine theta. So I'm going to write this as 8, 1 minus cosine theta over 2 times 2. And I'm going to take this 2 out with that 8, and what do you get? 16. And now I have 1 minus cosine theta over 2. If I plug in that formula, I'm going to have sine squared theta over 2, half of the angle that I see right there. So I get sine squared theta over 2. And that's what I'm going to plug in inside my integral right here. We get the integral from 0 to 2 pi. Square root of 16 sine squared theta over 2 d theta. What do we do with our 16? Take it out in front and it becomes 4. And what happens to the square root of sine squared? Sine. Now I'm going to make u be theta over 2. Then du is 1/2 d theta, or 2 du is equal to d theta. So this becomes 4 times the integral of sine u times 2 du. So that becomes an 8. What is the integral of sine? Negative cosine. And I'm going to substitute for u. And then that goes from 0 to 2 pi. So I get 8 negative cosine of 2 pi over 2, which is pi, minus negative cosine of 0. What is cosine of pi? Negative 1. Multiply by the negative in front. It becomes a positive 1. And then the two minuses are going to cancel. And so I get 16 units. The arc length is 16 units. Whatever your units were. Question? Right here, this is negative cosine of 0. Cosine of 0 is 1. Multiply by negative, you get a negative 1. Multiply by negative, you get a positive 1. Yeah, it didn't cancel on us. Any other questions on that? Okay. I am going to skip the classwork for the moment, do the surface area, and then put the classwork problems up there for you guys. You'll do them both at the same time at the end. That way those who finish early can leave early and time isn't wasted. So we're combining the classwork problems at the end. So surface area, let f be a function whose derivative is continuous on an interval, alpha to beta. The area of the surface formed by revolving the graph of r equals f of theta from theta equals alpha to theta equals beta about the indicated line is as follows, and we have two of them. So the question is, what is the polar axis here? The polar axis is your x-axis. It's that horizontal line, the horizontal axis. And the line theta equals to pi over 2, this one right here, is your vertical axis or your y-axis. Okay, so there's our two formulas. I'm actually not going to derive this one. It follows just using the derivation of the last one and realizing that f of theta sine theta is our radius. So that's the radius from the center to the function. Sorry, not from the center, from the axis of revolution to the function. That's our radius. Axis of revolution to the function, that is what we're using. So this f of theta sine theta, this is our y. F of theta cosine theta, this is our x. And we only do these set up to be about the vertical and horizontal axis. Okay, so let's go ahead and do an example. Find the area of the surface formed by revolving the circle, r equals to f of theta, equals cosine theta. And I don't know why your book uses this notation all of a sudden, but it does. So I just put it in here so you get used to it. It's just the same notation we had before. You can cross off that f of theta there and just call it r if you want. R equals to cosine theta about the line theta equals to pi over 2. So our equation for that, which one are we using? The first or the second equation on your sheet? The second. And it says it's 2 pi integral alpha to beta. And your axis is going to be x, so it's going to be cosine. So that's the other form for what's on that sheet. That means I have to go ahead and find r squared, r prime, square it, and simplify it for under our square root. So r is equal to cosine theta. What is r squared? cosine squared. And what is r prime? Negative sine. Square it. Sine squared. Now, r prime squared plus r squared. Yeah. We like it when it works out that nice. So then our integral becomes alpha to beta. We have the 2 pi out in front. The r is our f of theta, which is cosine theta. And then times the cosine theta from the formula, times the square root of 1 d theta. The trick is, I have to figure out alpha and beta. They didn't give it to me. So that means I have to sketch the graph of cosine theta. So, for cosine theta in rectangular coordinates, what interval do we use? Pi over 2. What is cosine of 0? 1. Cosine of pi over 2? 0. Cosine of pi? Negative 1. Do we know the pattern? Yep. And then in polar coordinates, make sure that you're labeling your axes on polar coordinates so that we know it's polar coordinates. That's our only clue that it's polar coordinates, is how we label that axis. So in polar coordinates, I start out on 0 with a length of 1. At pi over 2 it's 0. What angle do I go tangent to that 0 on? Pi over 2. And then at pi it's negative 1. Pi is over here. Where's negative 1? Back at the one we started at. Come out tangent, go back. So what is one circuit of that? What are the intervals of it? Yeah, 0 to pi. So this goes from 0 to pi. And that's one circuit. And we're actually spinning this about our line pi over 2. So if you're thinking about this, if you spin a circle around a vertical line, what shape do you get? A donut. You're spinning it the horizontal line. Yeah. If you spin it around a vertical line, you have a donut. Anyone hungry? Yeah, me too. You get a donut. Actually, I feel like baking donuts. I like baking cake race donuts. They're good. I like baking in general, just so you guys know. Yep, it's a lot of fun. Bribe you guys, get an A on the test, I'll bake cookies for you. Maybe we'll put it this way. Everybody get a 70 or higher on the test and I'll bake cookies. 70 or higher on the last test. How about that? That's a good bribe? Fourth test. So this becomes cosine squared theta. Square root of 1 is 1. D theta. How do you integrate cosine squared? And don't say, we learned that at the beginning of the semester, that's too long ago. Trig identity, yes. Power reducing formula or half angle formula or whatever it's called. Cosine squared is 1 plus cosine 2 theta over 2. So I plug that in, bring the 2 out, I have 2 pi over 2, integral from 0 to pi, 1 plus cosine 2 theta. The 2 pi and the 2's are going to cancel and you're just left with pi. Integral of 1 is theta. What is the integral of cosine 2 theta? Take a derivative. Yeah, when you put the minus on it, that's the derivative of cosine. But yeah, sine 2 theta over 2. Yes, that's exactly correct. from 0 to pi, plug it in, you get pi plus sine of 2 pi over 2, plug in 0. What is sine of 2 pi? 0. Divide 0 by 2. 0. Sine of 0 is 0. Divide by 2. 0. So I just get pi times pi, which is pi squared for an answer. Okay? Any questions on that? Question? Yeah. I'm giving you a different example on that one. Yeah. So you have to use the other formula for it. Okay, so let's set the classwork 2 up. On these, don't actually integrate them, just set them up. So go ahead and write down the formula for classwork 2, and let's knock that one out. And then we'll go back and get classwork 1. So we're doing this in backwards order, but that's the way the slides are set up. So f of theta equals sine theta, and you're doing this about the polar axis. So go ahead and put this down there for your f of theta graph. Sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, 3 pi over 2 is negative 1, and then 2 pi is 0. So there's your rectangular coordinate graph in polar coordinates. You start at 0, go up to 1, come back to 0. It goes once around on the interval 0 to pi. So you should be able to finish setting that one up from there pretty quickly. So just take it to the integral form. Don't worry about simplifying it, other than multiply your functions together, simplify those under conditions over the side. You guys want me to put it on the previous slide? Okay, compare your answers with each other, guys. Make sure everybody has the same answer. And there is the classwork 1 problem. Yeah, that extracted thing was just to figure out what the inputs are. I tell you what they are already. On this one too, you can just set it up and subscribe. You don't have to have it later. Just set it up and subscribe.
Well, the photos on my work are attached, so
Okay, I'll look at it.
I'll look at it.
Probably this evening.
That's fine, yeah. I'm busy with computers until then anyway, so, all right,
Okay.
thank you.
The people that were there for coffee. Yeah, it's, all about video? Yeah. Yeah, I mean, it's so. Yeah. Oh, they're still right. What? Coffee cups? Cafes? No, this is, that is, yeah. You just call it maybe. And then find out this is not the confidence that's much bigger. No, no, not the not the well, that's yeah, that's
Hey, Sam.
It's afternoon now.
You okay?
Yeah, I just watched that.
Oh. Did you finish? Did you finish presenting your research?
Not quite because I have to present tomorrow for seminar and then again on Thursday for the joint research thing that's what biology, physics, and chemistry department does. So, almost. Also, it's not good at doing the homework today.
I understand.
I hate it, so I'll do it today.
Sounds good.
So set down my stuff.
No, I'm just waiting on her to get her stuff out of the way.
Okie dokie. Oh, they're doing molecules today?
Oh, I'm probably going to want you to build models for me.
Okay.
So if you want to take this one, this will be yours.
Okay. And then just grab a tea.
Thank you very much for doing that.
In case you forgot. I'm actually wearing my black suit all underneath. It'll pop out if I need it. I'll just put a spell fall down and then I'll just turn it into a ninja suit. Later, Eric. leave day?
Oh, probably about. Oh no, it's gonna be before 3:15.
Well, when do you start?
It starts at 3:30, but I want to make sure that my computer works over
Oh.
there, so I'm gonna be going over early.
Like 3.
Yeah, I don't know when this session right now gets out. I have to check that.
Okay.
But let's get your question.
Okay. These are the ones I've done so far. And I was thinking of just following the format of a book, at least for the
Okay, yeah, you can do that.
management one. Okay. So they rather than like state that. I guess
You need to
proving-
prove that it's 1-to-1 and not 2.
Okay, so they didn't do that. They just
They
sort of
didn't do that.
assumed
They
that you would know
assumed it.
that.
Yeah.
But-
So
but
I
you want
want
to
to
see
see the
proof.
steps.
Okay. Is that and that is the same for here as well?
Mhm.
Okay. Also, how do you write a piecewise function? Block X fixed like that.
You don't remember. You don't have to define it onto the natural numbers. You can define it to the integers, from the integers to it, and then I had given you a function in class that went from the integers to the naturals, and so by function composition, you know it's equivalent, which is one of the examples I did.
Okay. Yeah, I looked at how you did it, and then I sort of
I mean,
just
if you
changed
want
the
to-
numbers to make it work for
If you want to do a complex function, you have to use. Where are you going to put it?
Well, it's right there. I started writing it out, but I could just use and to combine the two.
And this is part C, so that would be up here. Right, let 3 and the function f defined by f of x equals, okay, so that's, I'm gonna put it on display, and then I'm gonna do f of x equals 2, and then x slash left braces and then we're going to have x slash and then we are going to have, where's the function? 2x over 3.
Well, I have it. This is it right there, so just copy Command C.
Let's see.
Thank you.
And then x is putting there down.
Does it need a right bracket here?
No, I put a period there, so it shouldn't need a bracket. That tells it don't do anything. That it's not picking up this or these.
Ooh, oh, that's nice.
That's what didn't look so nice on that one. Let's do center. Let's do center. Right. Yeah.
Wow.
Let's do left and right. Yeah, that looks better. Left and right. Then we can put little commas right here. There you go.
Thank you.
You're welcome.
And am I starting this the right way for the last one? Say that it's true.
Only if you know something about X. This is a set of all X that are equal to that.
Oh, then I have to say then X and Z such that X is
So I think what you're trying to do is say that this is equal to this.
yes. Okay. Okay. Yeah.
You got sunburn.
A little.
Yeah. How did it go?
It was okay. I mean,
Got you 15 hours?
Oh, actually, I don't know how many hours I got yet. They haven't put it up yet, but I'm hoping to see the 15 close. It should be close at least.
Yeah.
So, yeah, it was worth like a degree grade for in that classwork.
That's good. Sunburn and all.
Yep. As long as it turns tan, then I can start again.
Yeah.
Sure. We'll go with the bright side of that.
In the meantime, don't scratch.
Oh my gosh, it's so painful. Like it's hard to have like clothes like on it, so I'm trying to wear the really like loose stuff.
You have aloe vera to put on it?
No,
You should get some. The kind with lidocaine in it works really well.
lidocaine.
Yeah, you get a Walmart.
I'll have to do that. I have
Trust me, I
lotion.
burned myself.
Oh yeah. All I've been able to put on is lotion, but I've been keeping it moisturized since then. I apply lotion like 3 or 4 times a day. So
Yeah.
that's helping. My face is so much better. It was hurting to touch it, but it doesn't hurt anymore. It's just red.
Color. Color's always good.
Yeah, I got it on my hand, like right there, and then on my feet where my sandals were. I have weird markings on my feet now. Yeah.
Yep.
But anyway, with these proofs, I feel like I have a basic understanding of what they want, but I'm doing a lot of hand waving. I think I really don't know how to like actually like prove it.
Okay, so which one are you looking at first?
3C. I know that if we
What is the set for 3C?
by the definition of whatever we're trying to prove.
3Z.
Oh.
So 3Z, the integer multiples of 3. So
Prove that they are denumerable. In order for them to denumerable that chart back
it has to be
here,
1-to-1 and onto a subset of
it's
the.
got to be both
rational.
countable and infinite, right?
You
in order
just
for it
show
to be
it's
denumerable.
1-to-1 and onto a subset of the natural numbers.
Okay.
Okay, so we don't ever say let the set B and Z. We say now 3Z is contained in the integers. You know, yeah, see, we have to find f. Your goal is to find a function f that maps the integers to 3z.
But
And
if this has z in it, then we know it's in the set of z, right?
yeah, but you have to figure out what your function f of z has to be equal to what.
In order for it to be 3z,
Yeah.
uh,
So what should it be?
what should f be?
Yeah.
3?
3 times what?
3
Yeah, 3 times lowercase z for each z in there. And then you have to show f is 1-to-1. F is onto. And then from class, I didn't actually prove it, but I gave you the function for it. I showed that the integers is equivalent to the naturals. And so you have something equivalent to the integers, which is equivalent to the naturals, so you apply transitivity, which I did in one of my examples. Remember?
No. This one?
No, that's not true.
Definition.
Let's see. Right here. So let's go before that. I had written it down. Where did I did it right here. The function you would use is f takes z to the naturals. You're going to take even natural numbers. You're going to, if x is greater than 0, it doesn't matter. You're going from the integers to the natural numbers. So you want to take your positive integers to the even natural numbers. So then f of x would be equal to,
You want it greater than or equal to 0, right?
2x if x is greater than or equal to 0. And then you want it to be odd natural numbers, so 2x plus 1. If x is less than 0, we want it to be 2 times the absolute value of x plus 1. We know it's negative, so I can actually write it a little bit easier. It's not quite so scary. So x is negative. Negative times negative gives you positive. Add 1 to it. So this function right here is going to show that z is equivalent to the naturals.
Okay.
Because this is 1-to-1, this is 1-to-1, and it's on to all of your natural numbers because you have all the evens here, you have all the odds here. So that gives you on to, it's going to be -1, not +1. Because if x is -1, then you have +2 minus 1 gives you 1. You want it to start at 1, so you need a -1 to compensate there.
Yeah.
So over here, all I did is because I knew that the integers is equivalent to the naturals, I know this is equivalent to the integers, and I know equivalence is an equivalence relation, so I know that this one has to be equivalent to the naturals by transitivity. So you're mimicking that proof for your last two, for C and H. You have to figure out what function to use, but the rest is going to be very similar.
Okay.
I have a question on for A. If we're following the same guideline, is it okay if I write A to be 1/n for n naturals rather than 1
Okay,
2?
what you have told me is that A is a set of all n in the naturals such that 1/n. So that's not quite a complete definition.
Mhm.
Let's go fix that.
But yeah, you can. Let A, y'all enter the naturals. I'm gonna put it, let A be all 1 over n, such that n is in the naturals.
So just backwards.
Yeah, you got it backwards.
What determines how we put it into our set definition?
The such that, anything after the such that is the descriptor.
Mhm.
Anything before is what's in your set. So you're taking all your 1 over n's, and then the descriptor of n is n in the
Okay.
naturals. Mhm.
That's awesome.
That makes sense. So then, yeah. In fact, you don't need to go from Z, you can go from the naturals to A.
Okay. Then I don't need to say, and so A is equivalent to N.
Yeah,
by
you don't need
Hessian.
that, but,
So I can just say, therefore, A is equivalent to naturals.
yeah. So let A and B be in the naturals, such that f of A is equal to
That
1 over 8.
into the naturals too.
Mm-hmm.
Is there a way to fix this spacing? Because for instance, 1 over B is rated running into 1 over.
Yeah, so what I do when that happens to be a problem is I put it on display.
Okay.
So you just,
Put them in.
yeah, put them in
brackets.
backslash bracket, and
Okay.
that'll fix it.
Okay.
That make sense?
Mhm.
So we have to show that these two equations are equal to each other? For one, for 1 to 1, you set your A function A
F of A equals to F of B using the function that you chose for that one. I chose F of T equals 2 plus 3T. So when I plug in F of A, I get 2 plus 3A. When I plug in F of B, I get 2 plus 3B. Not going back to those previous functions at all. They don't have any impact on that problem.
these ones?
Yep, not at all.
But I
This
still
is
have
a
to
function I chose for this one.
But I still have to choose a function for mine, right?
Yeah,
I can choose anything?
well, I would suggest going from the integers to 3 times the integers. I kind of gave you a function over there at the top of your page.
Oh, that?
Yeah.
Oh.
Mm.
Oh, okay.
So display like this, or should I align it so that the A equals B is aligned with the 1 over?
A equals B is aligned with the 1 over.
Okay. And then I would still need the right arrow.
Yeah.
Just align the left.
Yep.
Should I just put that in a line then, or is there a way to do that
Yeah,
within
no,
a sentence?
no, you need to do it in the line. Mm-hmm.